My name is Derek Fang, and I'm with my group members.
Edwin Fang.
Bryce Smith.
And Arakel Turanian.
Today, we are here from FSE 100 Fall 2021 to present to you Project Smart Fan. Now, my team and I wanted to create this project because we wanted to develop a solution in order to combat the heat outside. Currently, there are many solutions in the market that do this, but they do not do it efficiently and effectively. That's why we created our product. With our product, though, it will be a cheaper alternative while also being able to maintain an individual's health. There are many types of customers that have influenced our design, such as the direct and indirect customers. Direct customers have been buyers, such as gardeners, farmers, and construction workers, while our indirect customers have been our competitors, such as Dyson, Lasco, and US Fanco. When we interviewed many of our potential customers, they told us many great insights and feedback. We learned that our product should have a good price range and it shall also have a convenient and easy to use interface system. So knowing this, we created our prototype. And when we showed our customers our prototypes, they gave us more feedback, such as it was too bulky or that it needed to be able to carry items. Knowing this, we created our final design requirements, some of which are it shall follow the user, it shall be easy to use, and it should cost less than $100, just to name a few.
For our mechanical design, we had a box-like structure, and we decided to make the wheels halfway through the bottom through cutouts. And also, we have a distance sensor on the front and also a servo motor on top of that box that sweeps with another distance sensor. We also have a mister system, and originally we had 2 misters, but we decided to cut that down to 1. So we only have 2 servos in total in the full design in our final product. In terms of the other parts of our mechanical design, we have a fan on top of the box at the front and a basket behind that fan. In terms of the circuit design, we have the Arduino connected to a breadboard through its 5-volt and ground of the power. In addition, we started off having 2 L298Ns, one to power the fan and one to go to the wheels from Arduino pins PWM. And we decided to relocate the fan's power source to the breadboard by the end. All of the sensors are controlled through Arduino in terms of the signal. And in the end, we had an 18-volt battery going to the wheels and a 9-volt to power the Arduino system itself. In terms of the software design, we first declare all of the variables for the distance sensor, the servo motor, and all of the other Arduino pins that we use. And from there, we start a while loop, and basically this will go until it hits 170 degrees on the servo angle for the sweeping servo, and then it'll reset. Now, during this loop, it'll basically be checking for the distance detected, and if the distance is the lowest distance detected so far in the while loop, it will update the minimum distance variable to basically have a lower distance in it, and also update the minimum angle variable so that we know what angle that was recorded at. So that at the very end, we can either tell the system to move left, right, or go forward, or stop if it did not detect something correctly. And for the rest of the software design, this is just an example of some of the things that we have, like the while loop, the turning, and measuring distance.
Through the demonstration video, we can clearly see that if the user is far enough from the device, it would actually move forward in order to follow the user itself. However, on the other hand, if the user is close enough to the device itself, it would actually reverse as a consequence in order to avoid collision with other objects and people in its path. When speaking about the logistics and resources of our project, it actually came out in the end to around $60 in total. Now, this cost was based on all the motors, wood, sensors, spray bottle, Arduino board, all combined. And compared to the cost, our budget was actually around $70 in the first place, which is relatively good. And this led to our final product cost, which came out to be $100. This was based off other competitors' prices and their devices. And when creating the project itself, the prototype itself, our team was actually really enthused and determined to create a great product. And while many of us had the same tasks and roles in mind, we had different individual goals in mind, which would create this project to higher lengths and heights, in the end creating a greater value product while keeping it at a low cost.
When we look at current misting fans that are on the market, we come away with two that really stood out to us, and that was the Schaefer Vera misting fan, which runs around $1,200 and weighs 56 pounds, and the next being the Honeywell Outdoor Portable Evaporator Fan, which costs around $500 and weighs around 45 pounds. When we compare these to our design, we see that ours is significantly cheaper in price and lighter in weight. It is much more portable as it is on wheels and it will accompany the user. It's capable of carrying items through the basket feature we implemented, and is more intelligent through the coding and the electronics we put into it. The lessons we learned throughout this project was that working as a team is crucial in this type of project, as we typically split the work up amongst ourselves, as it allowed for us to make the most use of our time. And we also found to always checking our work was extremely beneficial, especially when it came to code, as we often found mistakes. Things we could have done differently, we could have used a stronger power source from the beginning, as we found later on that power was one of our main issues. And another one of our main issues was weight, which is why we could have also made a smaller design. So our design focused on a way to combat the heat, and it catered to our customers' needs through the interviews we conducted. We found out what they wanted, and we catered to that. We began our build first with the mechanical construction of the box, then we implemented the electronics and the fan and all that, and then we tested our build, and that is how we finished our project.